So I am Lindsey, and we have Amber here as well. We are going to co-present this session, and it's going to be more of a discussion than anything. So before we jump into discussion, and we'll be working on a Jamboard together and talking about student work, we wanted to kind of zoom out a little bit and see, well, where do our students see fractions, at all different levels? Where is this coming up? So I took some sample questions from the internet, so these were free to share, but from the CASAS, some examples of where do students have to reason about fractions. Here's one about being able to decide, okay, well, what's half price? And then here's a higher level question that has to do with plotting lines, and there's using that rate, 1 to 3 looks like a fraction with these slopes. The table 11, 12, representing by shading in wholes. Well, what is 6/8? What does that look like? Or equivalence, being able to identify equivalent fractions or equivalent numbers, being able to calculate area with fractional dimensions. On the GED test, being able to put fractions in order from least to greatest that have different denominators. Working with fractions in problems that involve volume or surface area. On the TEAS test, being able to choose an algebraic expression that best represents this situation, and there are fractions within the answer options in these equations. Like how do I deal with that? What does that look like in algebraic notation? Or maybe a problem like this. You have a variable in the denominator, or you are multiplying mixed numbers. The AccuPlacer, dividing fractions, finding the decimal equivalent, subtracting mixed numbers, having fractions within an equation or in inequality, where there's more than one step that I need to use to solve that. Thinking about a context problem when they're talking about budgeting for half the time and then a second person third of the time. And what does that look like for the third person then that's brought in order to make one full-time position. So I have a third, I have a half, and now what do I need to make one full-time position? Being able to reason through that problem. And then this problem is more at the college level with the AccuPlacer test, but again, you see fractions, right? Like they never go away no matter what level of math we are working on. So this idea of understanding the concepts behind fractions and fraction computation, how to represent them, what Liz was talking about in the morning with the number lines and being able to reason and explain our answers and how we know this is the right answer is important because it's foundational for all levels. So we're going to spend most of our time today on looking at student work samples and discussing them. These are the two problems we're going to focus on. We saw this top problem in one of our breakout rooms today. This bottom problem we were not able to get to, but it was supposed to be in the third breakout room session, so you can certainly go onto the Padlet and try out this problem later on as well if you would like to. But these are the ones we're going to look at, and we have some sample work. So Amber is going to put a link to the Jamboard in the chat, and we will move our conversation to that space for the remainder of the time we have together. If you have trouble.
Oh, sorry, Linz. As we're looking at trying to get engaged, we do not want technology to be a barrier. So if you are unable to chat with us right on the Jamboard, which is obviously what we're hoping for, please feel free to throw things in chat or unmute yourself. We want you to be able to participate in any way that you feel comfortable, and the more the ideas that we can get together, the better. And we're going to save this Jamboard so that and have that available, I'm guessing, on the Padlet, so that you are able to kind of come back and see what your colleagues were thinking. So please feel free, engage right on that Jamboard or in chat or unmute yourself. All are welcome and encouraged.
Thank you for saying that. So to start off, we have, I see some people joining. Like Amber said, participate any way you can, whether it's via Zoom or Jamboard. But we have 3 examples of student work up on the screen, and that are solutions to this problem. And first, we just want to gather your thoughts on what do you notice and what do you wonder about the student work samples and what kind of understanding they're showing. So we'll be quiet for a couple minutes, let you type in the chat or on Jamboard, and then in a couple minutes we'll share some thoughts out loud about what you notice and what you wonder about these samples. Give you another minute or so. I see comments coming on the Jamboard and in the chat. That's awesome. Okay, so we're noticing a lot of things, which is the first step when we're, this is formative assessment, right? The title of this session. And so we're trying to find out, like, well, what do our students know? What is my next instructional move? What do they understand? What do they not understand? So we're noticing many things, which is awesome. And including some answers in the chat. The student A has naked numbers. There are no units. The other 2 do have units, and they were able to incorporate minutes into their answers instead of just fractions. And there's an error in the computation in student F, but they were still able to get 160 minutes. And so just noticing these things, right? Like that's nice to kind of take a moment and just look at student samples, look at oh, that's a good wondering. Yes. Look at samples of work. What's the array of options? Because like someone said, they all have a different way of getting to the same answer, right? And there's a lot of richness there when we then talk about it with students. So I want to then, now that we've had a chance to kind of notice some things, I want to move to page 2, where we're going to ask more specific questions about the same pieces of work. So on page 2, the arrow up at the top in the middle of your screen by a box that says 1 out of 13, you'll want it to say 2 out of 13. So here are some specific questions now that we can ask when we're thinking about this, these pieces of work. Okay, what does this student know how to do? What questions can we ask this student or these students to explain the choices they made? What do you think they would say? And then how does the student work show understanding of fractions? So we're going to give you another couple minutes to pick one question you want to answer, or all 3, and write some thoughts either in the chat or on the Jamboard. And then I'm going to ask for some people to unmute and kind of share what you're thinking about one of these questions as we're looking at this student work.
The slide is alive and I'm loving everything that's happening here. I also see there's some awesome stuff in the chat about what they want to ask students. Um, so maybe we should start with looking at what do students know? What do these students know? So I think it's really easy sometimes for us as teachers to kind of look at the deficit, like what are they missing? And I think it's a really awesome shift for us to do, to think about and consider, okay, where are we starting at? What do these students know how to do? And so there's lots of different things that we can see that students know how to do. So student A, I see a lot of different things that the student knows how to add fractions. We feel pretty confident that they can add fractions with a common denominator. We can also see that the student knows how to convert an improper to a mixed number. So student A is coming in with lots of procedural knowledge around fractions. but we still have lots of questions that we would say. Student B, we're seeing that they're more comfortable with time and whole numbers than they are with fractions, so they have a workaround. Does anybody else want to say something that they can see about what student B knows? Yes, feel free to unmute. What do we know about what these students know? What does student B know just looking at it? So somebody is adding in that they can see fractions made as a graphic. So they have a visual representation of fractions. That's really great. What do we think about student F? So somebody is saying, okay, they can see that student F knows the relationship between addition and multiplication. But maybe they don't, maybe do they know how to compute it? Maybe, I don't know. They know that multiplication can be thought of as repeated addition. Does anybody else want to jump in here and let me know as a teacher, what do you see that these students know? Is there anything that we're missing that's important to point out? Ooh, so this student is having some issues with this common denominator, right? Which is then really interesting because when you look in their math, there's some really curious stuff that's happening in their math. Oh, this is so lovely. Okay, so, well, we're talking about what they know about fractions. What else? What do we know about these students and what they know about fractions? Is there anything else that we're missing about where they're at in their understanding of fractions? So student F knows that they can add fractions, but they added their denominators instead of just because they're like terms, they didn't combine them like terms. The chat is chiming in and saying, it looks like student B feels the most confident of what this is in context. That's really interesting. Because the other two, their math doesn't have a ton of context in it, except for student F has it in the bottom. It almost looks like, is student F like two different students, or what are they thinking? Because their thinking doesn't seem to be completely aligned if they're understanding what they're doing. I'd love to hear what you're thinking on these three questions. Is there anything you want to, as a teacher, as you're looking at this work, what is jumping out? Does anybody want to take a risk and unmute?
I will. They're all jumping in and trying it and showing their work.
So at least they're showing some reasoning, right? So as a teacher, I can be like, hey, we've got at least something going here. They're all trying something. I love that, Joan. And they're all showing their thinking in a way that's probably authentic to where they're at in the process, right?
Yeah.
Oh, great. There's a great thing in the chat right now saying, one of our questions we could ask is ask our students to go back and read. What is the question asking? I saw some participants earlier saying there's naked numbers here. So a lot of this isn't in context. So what does 2 2/3 mean in this problem? What does that mean for me? And why do I need to know that? Or in F, how can I have 2.3 hours but a fraction that's less than 1? How does that work? Tell me more about that.
I think student F, they have at the beginning 2/3 times 4/1. And then next to that is the addition. And then below that is the, changing it to minutes. It seems like they're they have a bunch of ideas about things, but they're not confident in any of those. So maybe just how it would really be helpful if that person could see, have it drawn out specifically, like on a number line or in the bar graphish sort of things, the fractions like that, so they can get the concept of addition and multiplication and kind of separate those in their brain better.
Yes, Lisa, I love how you communicated that. I think sometimes as teachers, we would say, oh, look at all these different kind of work that the student has. Look how many different entry points they're using. But I do think it's important for us to remember they're probably trying a lot of different things to see what fits. And yet the one that they put a box around was that 8/12. So it's hard for us to know, do they have a really strong understanding of what this math actually means, or are they just trying to math and hoping that something works? And then really trying to make that connection to, you boxed this thing, how does that relate to the other work that you had, and having them maybe slow down. Lindsey, anything else that you're noticing?
I'm loving all of these comments. I think too, to keep the conversation going, I want to add in on page 3 a couple more questions. About like, well, what would we do next? And the idea of like, well, what can other students learn from this approach of representation? Talking about how there's different ways of thinking about it, that Joan brought up, and then thinking, okay, well, what does student F understand? There's multiple ways of solving the problem represented in student F's work. So what can we learn from this? What can other students learn from this? And then also, what would I do next? Based on the work that I see. And one question I have is to help maybe clear up some potential misconceptions. Would bringing in a number line that Liz was talking about, would that help the conversation? And if so, like in what way? How could that help? If it would be helpful. So I move to slide 3, if you're not seeing it. Same work, we can still add in comments from the previous slide as well, but just adding a couple more questions to the conversation. Where would we go from here?
And maybe we can look at it from each individual student. So maybe you are working with student A. Where would you go with student A? Like, where we sometimes refer to it as push and support. How can we push them further in their thinking, but support them in their areas of need? So if we looked at student A, only because A is first, it doesn't, and nothing special about A, but how would we help student A support them into getting an answer that's more appropriate for this question?
Yes, I would ask student A, 2 2/3, what are you referring to? Because maybe they did the math, but maybe they don't really know what their answer means.
Which is really common. We see that a lot, right? Where we see students who are like, oh, there's numbers. Oh, I got this. Now I'm going to calculate something, because maybe it's even one of those speed things. If I can do this quickly, I look like I'm smarter. I feel more confident. So I know that I can just do this. And it's really, I think it's interesting. If you see their scribble, they wrote 2/3 as like a sidewaysy kind of fraction, and then changed it to an up and down kind of fraction. And so I kind of wonder, like, why would you do that? Those might be things I would ask. But I like that idea of like, so what does this mean? How 2 2/3? So if you were to go tell your boss, or if your boss said you're going to work 2 2/3 hours this week, how many hours are you working? how would you know what that was? Or like trying to kind of put that into context. I love this one. There's a green square that says, I like how you added the fractions. Are you done with the problem now? I like when we're asking them, like, is there anything else we could add to this problem? What else are you thinking? I talk a lot about naked numbers in my class. So that would be a thing I would say. What about student B? What do we know about student B?
I think student B really seems to understand the problem, the way that they wrote out even, Monday is this many minutes, once they switched it over to minutes. And so I think they get what the problem is. I'm wondering too, what you think about this. So they drew the clock with the hour with the 20 minutes divided up like that. So we've been talking about the number line, and that would be a good way to represent it. Now, it seems like this is a new thing that student B brought in, dividing up the clock that way. Would it be helpful to show like a number line way to solve the problem, and then show maybe student B's representation where you take, 20-minute increments like that and draw those kind of pictures using that sort of graphic idea to answer the problem?
Yeah, I actually think that would be really great. When I solved this problem, I actually made 4 circles and divided them like this, and then shaded in 2/3 in different colors, one for each day, and then looked at how many I filled in. I didn't take that picture and then have that like imprinted on my brain and use that as my reasoning. So a number line would be really interesting. This student, if you look at that top, if you think about what we did in the very last session of our keynote, and we talked about proportional reasoning, it looks like student B is understanding that 2/3 of an hour and 40 minutes go together. And so then it looks like with the work that we can see, it looks like maybe they have some proportional reasoning or some multiplicative reasoning happening in their head. But when I look at their work doesn't really show multiplicative reasoning. Their work still shows additive reasoning. So I might actually push this student to say, okay, how could I show this using multiplication? Or how could I show this in a different way? Because one of the biggest challenges that adults have is that they never fully move from additive reasoning to multiplicative reasoning and have that as a solid strategy. So as a push for this student, I might push them, because it's also hard for me to know if this student has a really good understanding of fractions, or if they're avoiding fractions, or if they're just using this intuitive way, which is really important, right? But are they able to put this in an abstract representation? So this student might actually be, in some ways, it could potentially be a lower level student in terms of the progression than A, but we aren't able to really see that. Kevin has a great question in the chat saying, for student B, what if it was 2/3 of a pound instead of 2/3 of an hour? How would my picture change? How fantastic is that? When we get into our units and oh, that is a beautiful question. I'd love to see what the student would say about that.
Yeah, I always like to challenge students with, you have kind of maybe an easy question here. 2/3 of an hour is 40 minutes, but yeah, if you couldn't break the 2/3 into 40 of a different unit, how would you deal with the number you're given?
Oh, I love that. Or even taking this, and I love what you're kind of thinking here, maybe the student does feel super confident with this strategy. Let's make it so that it's not as easy to use this strategy to solve the same kind of problem. So what if we ask student B, what happens if this person did this same walking schedule for 5 weeks? How much time would that take? Where it's that visual model might not be as easy, and they might have to think about, what if we did this for a year? How many hours would they have walked? So really taking this and making it and expanding it in a way that maybe doesn't fit nice and neat on a Post-it note, to kind of think, can they expand this reasoning? And then I love Kevin's question for, what if our unit rate is different, or what if our unit measure is different, and how does that change how we have to approach this? What, is there anybody else having anything interesting that they're noodling on? So obviously we talked about with student F that we might need to sit down and talk about, does 8/12 make sense? What do we know about 8/12 and what do we know about 2.3 hours? And how do we get fractions and decimals and minutes, and how do these all relate? And asking them to find that, I actually might really push student F. Ooh, Joan, I see your question. I think student F would probably be benefited the most from a double number line in this situation, to kind of step way back from the maybe the standard algorithms or that abstract representation, and go way back to that number line is probably the best thing for student F, to take a step back to then move forward more quickly. So there's a question in the chat. And so additive reasoning is like what student A is doing. So student A is adding up. So student A could have done what student F said they were going to do, that 2/3 times 4. And so 2/3 times 4 is multiplicative reasoning, meaning that they can scale up and scale down, similarly to what we did at the end of that keynote session. Student A is not able to see that they can multiply these, they have to add them up. So that when I'm looking at student B, I can't tell if they are doing 40 times 4 or if they're doing 40 plus 40 plus 40. So anytime we can get that, so multiplicative reasoning is using multiplication strategies to scale up or scale down, or to grow or to shrink. And we really want our students to see multiplicatively rather than just relying. So if you have students who can only solve 7 times 5 by adding 7 5 times, they are not thinking multiplicatively yet. They're still thinking with additive reasoning. Oh, such good stuff. Lindsey, the next slide I think is really interesting, and I think this group will have a really good time with it.
Yes, slide 4. Is that what you're talking about?
I was thinking, what's the next slide?
This one. This is what you were thinking?
The order.
Yep. So I will set that up. I agree. So these questions that we were on these sticky notes in the last couple slides, page 2 and 3, they're here. And we're going to put this Padlet on this Jamboard on the Padlet, so you will have these. But these are really general questions that we can use for any kind of student work that we're looking at. So that is here just in another way, but we already looked at these questions. The other thing that we wanted to talk about today is if I wanted to have then a classroom conversation, or if I am in a one-room schoolhouse and say I've collected student samples from the same problem. I've collected samples all week, and then I put together, randomized or anonymized, that's what I meant to say, anonymized the work and made some sort of whether it's a worksheet or whether I am talking with students individually through the process, like what order would I show these pieces of work in, whether I'm calling on students if I have a class and we're in a group, or whether I'm showing students samples of work, what order would I do that in and why? Like, what's my goal? What do I hope that they what am I trying to lead them to? What understanding? So there's different ways to think about ordering student work, and we're going to focus on this purpose too, like wanting to kind of deepen understanding and about a math concept. Like, I want to talk about these key mathematical ideas here. So if we look at slide 7, if you are on the Jamboard and following along, you can go to slide 7. These pieces of work, these same pieces are on this screen. But if we were going to either have a discussion as a group of students and they're all there to talk about their own work, or if we were to have this one-on-one conversation with just ourselves and a student, what order would we present these pieces of work in and why. And there's not just one right answer. So we'll let you think about that, but we would love to hear. You can unmute and share. You can write something on the Jamboard or in the chat. But is there a student you would call on first or show first, and why? And then where would you go from there? Any thoughts? Would anybody start with student F?
I would probably start with student F just because they started with 2/3 times 4/1 as their first thing. And they went on to a number of different things, but maybe try to circle back to what were you thinking when you started this? Where did that come from?
Thank you for sharing. Anybody else? Would you do the same? Would you do something different?
I would probably start with student B because they have a little drawing of a clock and or maybe it's a pizza. It has nothing to do with the time. But I think I would start with that one and go through it and have them explain how they got 160 minutes.
So there's that visual that you could grab onto and then maybe start from there. It was interesting. Go ahead. No, I'm
Sorry.
right. Go ahead.
Oh, I was just gonna say, I guess, is the point of this them getting the right answer, or is the point of them knowing how to work with fractions? Because I feel like student B, I mean, they could be avoiding fractions and just changing it to minutes. Do we want to go that route? They definitely got the right answer. But if the whole point of the lesson is working with fractions, you know, it's a way to like check your answer in the end. But if you want them to know how to work with the fractions, do you want to go with somebody else that is actually manipulating fractions?
Which is awesome because that ties into what I was just going to say. So for me, we're working on unit conversions in my class right now. And so I think it would be really interesting to see where would I want to leverage this, because I have a lot of students who are super confident in student A's work because we've been in this working with fractions, and they become little like fraction monsters, but they can't actually. So if I were to say, what's going on with student B and like, what does this mean in context? It would be really different. Now, if I was looking at, we've been doing a lot of these concrete representations with clocks and things, and I'm trying to transition them into fractions, I might order them really differently. And so what's really cool is that as an instructor, you know what your purpose is, you know who your students are, you know what your goals are. And so all of these could be leveraged in a different order for a different purpose. And thinking about what do you want to highlight that day? And you could even save this work for later and come back and look at it with a different lens or a different purpose. And so that's the magic and the art of this work, is that you are the professional and you know your students the best. And so thinking about where do I want them to go? What's the nugget I want them to leave with may completely change. So for me, I might want my students to really think about making connections between my answers and if they're reasonable. Well, if I was really looking at that, well, then I might want to lead with student F, because student F has an answer that's not reasonable in context. So thinking about what your objective is could really change how you would order these. So I really love that point you made. And
Kevin,
yes.
go ahead.
No, Lindsey, please.
I was just going to say, Kevin, I just see your comment now. that it's fair. I mean, I don't know who to call in first. It's hard to decide, like, what am I going to do? Yeah, but I like that you're including positive feedback for each student. Student F has the shortcut 2/3 times 4/1, that procedure. And yeah, it's quick, less writing. Student B has the visual to get the minutes, and student A has the best procedural steps and work shown, in my opinion. Okay, so yeah, there's lots of different entry points, lots of different ways of representing this. And so I agree. If I was trying to make sure that my students knew how to procedurally add up fractions, then I would want to leave students with the realization or the understanding of student A. But if I was really wanting students to move from just solving the problem and using the procedure to being able to put it in context, then I might want to spend more time on student B and talking about that and having that be what my students are left with. And student F has kind of a mixture of both, which is awesome. So yes, there's that computation error and maybe an understanding error, but it has kind of both in there as well. So your purpose may change. It may be different from others. You know your students and what you want them to understand. And I think, you know, if there are misconceptions around the ideas of fractions and what it means, or how does it line up with the minutes, and if that becomes difficult in the conversation with one student or multiple students, bringing in number lines that we talked about today, I think could be really beneficial. There was a group from the last session that we made a number line where we had, what was it? These holes, which were the hours. These were the hours, and then partitioned it into thirds so that then students could use this number line to see 2/3 4 times and make those jumps like we did. I don't know if someone wants to jump in and do that, but making those jumps from 0 to 2/3, and then another one from 2/3 to 1 1/3, and another one from 1 1/3 to 2. So they're making these 4 jumps. But so bringing in that, but then also bringing in this idea of a number, or the double number line, where you have another set of labels, right? So yeah, someone's writing minutes. How would this then correspond? 1 hour is how many minutes? And so filling that in can help kind of see how, oh, okay, this 2/3 hour is actually 40 minutes. If I break that hour up into 3 parts, that 2/3 is 40 minutes. And that's what I am repeating 4 times. So bringing in a visual like this could be a helpful strategy to help clear up any misconceptions as you are talking about student work. So we are at time. On this Jamboard, you will see that there is actually, in the future slides, there's another problem and student work. We didn't necessarily think we were going to get that far. We just had more than enough, but this will be on the Padlet. So if you want to go back and look at different samples for the division problem, feel free to do that. But otherwise, I know Marisa is going to put the link to the flyer again in the chat, because that is where you will find the evaluation, and filling that out will give you the CEUs. So thank you so much for today and all of your math thinking and sharing. I hope it was valuable for you.